In this lecture, I am going to solve few problems on the discrete time Fourier transform. Before that, we will see summary on the properties of the discrete time Fourier transform. Similarly, this type of summary you have to make and paste in your reading room. So first we'll see property, and this x of n is a periodic signal, right? And Fourier transforms are periodic with a period 2 pi. Now the first property is periodicity, that is like this: e power j omega plus 2 pi. That is omega plus t, or t plus t is equal to x of t, that is x of e power j omega in frequency domain. Next one is linearity property. If it is homogeneity plus additivity, in the frequency domain also we will get homogeneity and additivity, but with respect to Fourier transform. Similarly, time shifting, when we shift in time domain, in the frequency domain, it will be e power minus j omega into n naught. If this is minus, we'll get minus. If this is plus, we'll get plus. Similarly, frequency shifting, if we want to shift in a frequency domain, so in the time domain we have to multiply with e power j omega naught n. Here omega naught is a constant, and it will be shifted by omega minus omega naught. If here plus, we'll get minus. If it is minus, we'll get plus, right? Opposite. Now similarly, the next property is conjugation property. That is, if we do conjugation for x of n, in the frequency domain we have to do conjugation as well as the omega replaced by minus omega. Then time reversal is, if in the time domain we do the reversal, in the frequency domain omega will be replaced by minus omega. Then time expansion, looking like time scaling, but the property is somewhat different compared to continuous time Fourier transform. That is, if xk of n is equal to, so this should be equal to n by k. That is, we will get only get integers, right? The value will get integers only. So that's why n should be multiple of k. That means this n should be approximately like this, rk. If it is 0, if n is not multiple of k, then this omega replaced by omega k, j omega k, whatever the value here, so we will get here multiplied with omega k. That means here we will get expanded, but in the frequency domain we will get compressed. Next two properties, convolution and multiplication. That is, when we do convolution in time domain, so we have to multiply with in frequency domain, that is x of e power j omega into y of e power j omega. Similarly, if we do multiplication in the time domain, we have to convolve in frequency domain with over one period only. That is very important, 1 by 2 pi, and this convolution will be done over one period. So it is looking like x of k into h of n minus k. So here variable theta, that is x of e power j theta into y of e power j, this is omega minus theta, that is t minus k, right? Or h of n minus k, etc. The next property is differencing property. That is the first difference, x of n minus x of n minus 1. So it will be, see, n minus 1 means we will get e power minus j omega. X of n means x of e power j omega. So if I take common, so this will become 1 minus e power minus j omega into x of e power j omega. Now what is the opposite is accumulation. So that is a x sigma k is equal to minus infinity to n. Remember n, and here x of k. Then whatever we here multiplied should be division, but whenever we do the summation, we will get average value or DC value. That is decided by this pi into x of j0, as similar to the continuous time Fourier transform, into del omega. But here the frequency domain, anything is periodic in nature. So that's why we need to represent like this: k equal to minus infinity to infinity del omega minus 2 pi k. So it is a periodic. Next, differentiation in frequency. So when we want to, or when we have to differentiate in frequency domain, in the time domain we have to multiply with the n. N into x of n means j into d by d omega of x of e power j omega. Next one is conjugate symmetry for real signals. That is, if x of n is real, that means this conjugation will be same. That is, x of e power j omega is equal to x conjugate of e power j omega. Or this one also can be written like this. So if this conjugate is coming this side, x conjugate of e power j omega is equal to x of e power minus j omega. This is also right. This is also right. Similarly, when it is real, so real of x of e power j omega will also equal to real of x of e power minus j omega. If we take imaginary, we'll get minus imaginary of x of e power minus j omega. Now magnitudes will be same, but the phase will be in, so this is like a even function, this is like a odd function. So phase will be odd function, the magnitude will be even function. So this is even, this is odd function. Similarly, we continue that conjugate symmetry for real and even signals, that is x of n is real and even, then x of e power j omega is also real and even. Similarly, if x of n is real and odd, then x of e power j omega will be purely imaginary and odd, right? So even, odd and odd. Here real means we'll get real, but in this case odd signal means real means we'll get purely imaginary term. Similarly, for even function of x of n, odd function of x of n, the Fourier transform will be real of x of e power j omega. Here we'll get j into imaginary part of x of e power j omega, right? The last one and important relation is Parseval relation. That is, if we want to find the energy in a time domain, that is n is equal to minus infinity to infinity mod of x of n whole square. In the frequency domain, we have to integrate over one period and mod of x of e power j omega whole square d omega and divided with 2 pi, right? So this is about the this properties summary, right? Then we'll solve the problems on these properties. Now, how to do these properties? Suppose the question is given like this: 1 by 2 power n minus 1 u of n minus 1. So it's looking like a time shifting property. So first we have to find the without time shifting, that is 1 by 2 power n u of n. This is a basic signal, so we know that Fourier transform is 1 by 1 minus a into e power minus j omega. Now if I shift this, that is n minus 1 u of n minus 1, what will be the Fourier transform? N minus n naught means e power minus j omega n naught. N naught is 1. So e power minus j omega by 1 minus 1 by 2 into e power minus j omega. Right? So as simple as that. Next one is 1 by 2 power n mod of n minus 1. Now we know the basic signal is 1 by 2 power mod n. So in the first lecture we found the Fourier transform of this signal. A power mod n means 1 minus a square, right? So I will write the formula here. A power mod n means 1 minus a square by 1 minus 2a cos omega plus a square. So 1 minus a square means 1 by 2 whole square, not square, by 1 minus 2 into a, 1 by 2 cos omega plus 1 by 2 square. So 1 by 4 means we'll get 3 by 4. And here 1 plus 1 by 4. So 5 by 4 minus 2 to cancel. So cos omega. This is for 1 by 2 power mod n. Now if I shift, so what will happen? 1 by 2 n minus 1. So simply we'll get, see, if I take LCM, so we'll get 3 by 5 minus 4 cos omega into e power minus j omega n naught. N naught is 1. So this is the Fourier transform. 3 into e power minus j omega. Whenever there is a shifting, we'll always get e power minus j omega terms. Right? So this is about the time shifting property. Next one we'll see this one. This is question number 2. A part is delta n minus 1 plus delta n plus 1. So we know that for delta n, what is the Fourier transform? Simply 1. Now if I shift, what will get? Delta n minus 1, the shifting will get e power minus j omega into 1. So 1 will be. Similarly delta n plus 1. So Fourier transform will be e power minus means minus, plus means plus. So we have to add both. That's why delta n minus 1 plus delta n plus 1 Fourier transform will be e power minus j omega plus e power j omega. So what is this? For j theta plus e power minus j theta by 2. If I divide and multiply with the 2, so it is cos omega, so it will become 2 cos omega is the Fourier transform. Now if I assume this is some x of n. Right? Similarly, you can find this one also. So I'm I'm finding directly delta n minus 2. So Fourier transform is delta n means 1 and it is shifting. So e power plus, we'll get plus j omega 2 minus e power minus means we'll get minus j omega 2. Now it is looking like j theta minus e power minus j theta. So it should be, we have to multiply and divide with 2j because e power j theta minus e power minus j theta by 2j. So we can represent by sine. So 2j sine 2 omega, right? So this is this problem. So next we discuss this one. So we need to find the inverse Fourier transform of this segment. So x2 of e power j omega is given. From 0 to pi it is 2j. From minus pi to 0 it is minus 2j. That means what is the periodic? Minus pi to pi. So period is 2 pi. Right? Now how to find x of n? X of n is equal to 1 by 2 pi integration over 1 period x of e power j omega into e power j omega n d omega. This is, so we have to find x2. So x2 of n, x2 of e power j omega. Now it will become 1 by 2 pi. Now this integration will be split. That is minus pi to 0, minus pi to 0. We'll get amplitude or signal is minus 2j into e power j omega n d omega plus 0 to 2 pi 2j into e power j omega n d omega. Now minus 2, 2j if I take common, so 2j by 2 pi, and this is minus e power x means e power x only by j n, because we are differentiating with respect to omega. So e power x integration means e power x. Again we need to differentiate j omega n, so we'll get j n, and the limits are minus pi to 0. Next, so 2j is out, so it will be e power x, so e power j omega n by same we will get j n, and this is 0 to 2 pi. So 2 cancel, and this is j pi. So j by pi. So if I substitute 0, I'll get 1, and minus, if I substitute minus 5, we get e power minus j pi n by j n, plus similarly e power j 2 pi n minus 1 by j n. So this is x2 of n. So we need to simplify. So if I take j n common, so I'll take here j by pi, and the overall j n is common, right? So this is, see here, minus of 1 minus, so we'll get minus 1 plus e power minus j pi n plus e power j 2 pi n minus 1. So what is this? See, again j will be cancelled, so this will become 1 by n pi into, now what is this j 2 pi n? So it's always 1. So do you agree? So cos 2 pi n plus j sine 2 pi n. If n is equal to 1, 2, 3, so this will be 0. So 1, 2, 3, so it will be always 1. So I can write like this: minus 2 plus 1 plus e power minus j pi n. So what is this? 1 by n pi e power minus j n pi minus 1. Similarly, so this is the x2 of n. Now this cos n pi will be like this: cos n pi minus j sine n pi. Again this will always 0 for all n, but cos n pi is minus 1 power n, because when n is odd, so it will become minus, when n is even, it will be 1. So that's why the final x2 of n I will write as like this: 1 by n pi minus 1 power n minus 1, right? So this is the inverse Fourier transform of the given segment, right? So next one, again we need to use the properties. For x of n is x of e power j omega, then we need to find the Fourier transform of x1 of n, which is the shifted versions. Now I told you when we did the problems on the continuous time Fourier transform, so if 1 minus n is there, so always take minus common, then make it as n minus 1. Similarly this one also, x of, if I take minus common, this will become n plus 1, right? Now what we need to do first? So first we will do x of n is the Fourier transform is x of e power j omega. Now we'll do the first reversal, x of minus n. So what is the reversal build? E power minus j omega. Now if I do the shifting, that is n minus 1. So simply e power minus j omega into x of e power minus j omega. Similarly, same x of minus n I will do first. So Fourier transform will be x of e power minus j omega. Now if I do the shifting, so what will get? E power j omega into x of e power minus j omega. If I add these two, the final answer 1 minus n plus x of minus 1 minus n. What is the Fourier transform? So e power minus j omega x of e power minus j omega plus this one e power j omega x of e power minus j omega. If I simplify, that is e power minus j omega will be common, so it will become e power j omega plus e power minus j omega. So what is this? So multiply with 2 and divide with 2. So what will get? 2 cos omega into x of e power minus j. So that is the Fourier transform. This is right. Next we will do one more question. This is the one. X of n is x conjugate of minus n plus x of n by 2. We know x of n means the Fourier transform is x of e power j omega. Now what is x conjugate of n? We know, so this will be x conjugate of e power minus j omega, and we need to do minus, right? So x conjugate of minus n will become the Fourier transform x conjugate of, so reversal, right? So minus will become plus. Now we need to add these two, this one and this one, then what will get? x2 of n is equal to x conjugate of e power j omega plus x of e power j omega by 2. So one is conjugate, one is normal. So what we will get? So the imaginary part will be cancelled, then only will get real part, something like this. I'll take example. Suppose x of e power j omega is equal to, I'm just taking example, suppose 1 plus j omega. Now what is the x conjugate will get? It will become 1 minus j omega. If I add these two, so this imaginary term will be cancelled, we will get only real term. So what is this? So real of x of e power j omega. So this is the answer. So when we add conjugate and without conjugate one, we'll get only real, right? Next we'll see one more problem. This one. x3 of n is equal to n minus 1 whole square x of n. The moment you see this question, you may try to go for the time shifting, right? But time shifting we will apply only if x of n is containing some n minus 1, n plus 1, but it is not containing any shifting. So how to do this one? So just apply a minus b whole square formula. So a square minus 2ab plus b square into x of n. Then multiply n square x of n minus 2n x of n plus x of n. Now if I take the Fourier transform, n means what? J into d by d omega. N square means 2 times we need to do. So j square into d square by d omega square into x of e power j omega, right? So j into d by d omega into j into d by d omega. So j square minus 2 into n means 1 time differentiation, j into d by d omega of x of e power j omega plus, so x of n means simply x of e power j omega. So j square means I will get minus, so minus d square by d omega square x of e power j omega minus 2j d by d omega of x of e power j omega plus x of e power j omega. So this is the Fourier transform, this sequence, right? Next one we'll solve this one. Find the numerical value of sigma n is equal to 0 to infinity n into 1 by 2 whole power n. Now I told you this type of problems are will get in the GATE exam. That is, we know that x of e power j omega is equal to sigma n is equal to minus infinity to infinity x of n e power minus j omega n. Now if I substitute e power j 0, omega place 0, so it will become n is equal to minus infinity to infinity x of n. So that is, so what is this value? It's a average value, right? So that is the x of n or DC value generally. Now, so if I relate these two, but it is becoming from 0 to infinity. So what may be this x of n? So 0 to infinity, only one signal will be there, that is u of n. So we have to assume this is 1 by 2 power n u of n. Once we know the Fourier transform of this one, just we need to substitute omega equal to 0. So first we will find the 1 by 2 power n u of n. What is the Fourier transform? 1 by 1 minus a, 1 by 2 e power minus j omega. Next there is a n, so n into 1 by 2 power n u of n. So what is the Fourier transform? J into d by d omega of 1 by 1 minus 1 by 2 e power minus j omega. Now, so we need to differentiate. So it's looking like 1 by x formula. So I'll recollect d by dx of 1 by x, simply minus 1 by x square. So what we'll get here? Minus 1 by x square minus 1 by 2 e power minus j omega whole square. But we assumed this one term as x, so we need to differentiate this one. So one differentiation means 0 minus constant is 1. So we need to differentiate this one. So e power x means e power x into, again we need to differentiate this one. We'll get minus j. So this is the final output. So minus 3 minus, so we'll get minus so j into j, so we'll get j square. So j square again will get minus 1 into 1 by 2 is there, so 1 by 2 e power minus j omega by 1 minus 1 by 2 e power minus j omega whole square. But we don't require this one, so just we'll substitute 0 in this Fourier transform. So if I substitute omega equal to 0, so x of e power j 0 will become, see, minus minus will be plus, so 1 by 2 will be there, 1 by 2 into e power minus j omega, minus j into 0 by 1 minus 1 by 2 e power minus j into 0 whole square. So j0 e power 0 means 1, so 1 by 2 by 1 minus 1 by 2 square. 1 minus 1 by 2 means 1 by 2 whole square, so 1 by 2 by 1 by 2 whole square. So 1 by 1 by 2, the value is 2, right?